Hey everyone, welcome back again to HSP World of Chemistry. And now, my dear students, finally, because of huge demand from student side, that qualitative analysis, that is salt analysis. So, really, we want salt analysis. This time also, you have seen in NEET 2026 questions they have been asked. And I'm telling you from the very starting that all my dear students, 3 to 4 questions definitely they will come from salt analysis. Okay, so let's set go. Principle of qualitative analysis, salt analysis. The thing which is really the fundamental concept for the salt analysis. First, we will talk about these 2 3 points just for 1 to 2 minutes, and then I will let you know each and everything which is in your NTA syllabus given by whatever the syllabus NTA has provided. I will deal with those radicals only, right, which are in the syllabus given by NTA. Although NTA has given the syllabus, but acetate was not in the syllabus, but they have given question from the acetate also. So these things also I will keep in mind, that if they are logical and they are not given in the NTA syllabus, then I will let you know, right? So let's it go. Uh, Key points. What are the key points? You see, first, the fundamentals of salt analysis, that is solubility and reactions. So remember that solubility video I have made a number of times. If you don't know the solubility, I will make once again the solubility because it holds a hell lot of weightage. If you don't know which wing residue and which wing is wing soluble and you are doing the filtration, we should know the filtrate. Just like you are doing filtration of your tea, the filtrate will come down and the residue will remain upper side. We are going to have that filtrate as a tea, right? So the second thing is that classification for test of anions. First I will deal with cations and then I will let you know anion, because salt is made up of, when acid reacts with base, it forms salt and water. So salt is the combination of cation and anion. So total, how many cations are in your syllabus and how many anions are in your syllabus, I will deal one by one. If I talk about basic radicals, then Pb2 plus, Cu2 plus, Fe2 plus or 3 plus, aluminium 3 plus, nickel 2 plus, Zn2 plus, barium, strontium, calcium. Out of these three, one is not given by NTA, but we will deal with, right? Magnesium 2 plus and ammonium. These are the radicals for cations, if I want to say cations. And for anions, I will let you know after completing cations. So dry and wet test, this is not much important, right? So let's see salt analysis. So first thing, if I tell you this, though I have told you salt of cation and anion radical, and you see includes precipitate formation, precipitate exchange, and precipitate dissolution and forming soluble complexes. So these things are there. So frankly speaking, when I will let you know the salt analysis, we have to generally find out the color, which holds a hell lot of weightage. Right now, I'm making this video, and 99% things you will be able to understand, but 1 to 2% things they will go over your head. Why? Because once the solubility is not clear, you won't be able to get it 100%, right? So don't worry, even if 50% you are able to understand, then again and again watch this video. One day 100% you will be having this thing in your hippocampus. So let's start, let's it go. The first radical is ammonium. What is the first radical? Ammonium. This is in zero group. Why zero group? Because this is after fifth, sixth group. So at the last. So it is known as interfering radical. Interfering means whenever there is get together and somebody, you know that this candidate is a disturbing candidate. So you will say, hey, let him eat and let him go. Let him go, let him sleep. Okay. So then we will enjoy. So the ammonium radical is interfering radical. So first of all, they are going to deal with, and that's why it is being kept in 0 group. Now see, to identify whether ammonium is there or not, there are a number of experiments, simple experiments, but the best one is Nestler's reagent test. You see, this is the conformity test, Nestler's reagent, K2HGI4, K2HGI4 plus basic medium. This is known as Nestler's reagent, and it gives a brown precipitate that is known as iodide of Milan's base. Iodide of Milan's base. For this, reaction is not given over there. So let me take a fresh page and let me write down that reaction which is actually required over here. Now see, focus. So I will say A N S, my trick, ANS, brown water Nike, brown water Nike, ANS, brown water Nike. What is the meaning of this? The meaning of this is A for ammonium radical I will write down, N for Nestler's reagent I will write down, S for sodium hydroxide I will write down. Now this brown water is product HgO, Hg, NH2I. Everyone say along with me, HgO, Hg, NH2I. This is actually iodide of Milan's base. Brown color complex, iodide of Milan's base, right? Iodide of Milan's base, and this is brown in color, Now H2O plus NaI plus Ki, in my childhood I made it 1, 2, 3, 1, 2, 3, 4. Reaction is balanced. This is the balanced reaction. You have to keep it in your brain. Okay, now let me go back where I was. I was over here, the ammonium radical test, and it was over here, Nestler's reagent test we have done. Now, my dear students, simple test which you must have done in your school level, that is, take a test tube. In the test tube, add dilute HCl, dense white fumes of ammonium chloride. If dense white fumes are coming out, that indicates that ammonium radical is there because you added Cl and it has formed ammonium chloride. Okay, so this is all about ammonium. I hope that ammonium radical is very much clear. Yes, sir. Now, come to the first group radicals. These radicals are arranged in the increasing order of their KSP value, that is solubility product value, right? So if I say lead, silver, mercurous, all they will get precipitated as their chlorides. If you add dilute HCl, see, dilute HCl is the group reagent, remember that. In the first group, how many radicals are there? Ag plus not in slavers, mercurous not in slavers. They are there in first group, but they are not in slavers. Only one is in our slavers, that is plumbers, Pv2 plus. Their chloride, other chlorides, what's the difference? These elements chlorides KSP value is less, so they are easily getting precipitated. Rest of the others will require high concentration of chloride, and say they won't be able to get precipitated on adding dilute HCl. So on adding dilute HCl, if something is getting precipitated, that is indicating that either lead Pv2 plus, Ag plus or Hg2 plus is there, but for us only Pv2 plus is there. Now, what type of color it will form? So remember that all their color is being white color. They all are white PPT. What I'm saying, they all are being white precipitate. So your part is to remember they all are being white PPT. Can you remember this thing? They all will form white precipitate with dilute HCl. So this is the point to be noted, my lord. Clear? Now, so white color PPT we have got, and you should remember that these chlorides are insoluble in water. But out of these three chloride, one is being soluble in hot water. That is your lead chloride. My dear students, you have to put this thing in your brain that lead chloride is insoluble in cold water, but soluble in hot water. Hot water, it is being soluble. So whenever somebody is doing practical over there in the lab, that just professor is saying, Professor Kulkarni, no, no, I'm not talking about PV Kulkarni. PV is equal to NRT ideal gas, and here PV Kulkarni again and again is coming. Okay, no problem. So whenever we are doing this test in the lab, professor always say that always cool down your test tube under the tap water. So you will get white PPT, and this white PPT is Samba Ranga Swami, lead chloride. Lead chloride is white color precipitate. Got it, sir? Don't irritate me. Okay, you got it. Very good. Now, my dear students, now what you are supposed to do, lead chloride is there, and you know that PB, if you react with some chromate, PbCrO4 is yellow precipitate that you have studied in block D block, right? Now, this is okay. Done. So, see, it's written over here, PbCl2 is soluble in hot water. PbCl2 is soluble in hot water. Now, this is okay. Now, I was talking about something is given in D block, that K2Cr2O4. What is this K2Cr2O4? It should be K2CrO4. So it's a misprinting. So let me do the correction. It's K2CrO4. Potassium chromate. If you react it, then lead chromate will react with potassium chromate. Now, why it is going to react? I've told you in the starting, you won't be able to understand each and everything. All sorts of sodium, potassium, rubidium, cesium, and ammonium are soluble in water. Remember that. Let me write down this point, otherwise you won't be able to understand anything. All, make a note of it, okay? Where? In your brain. कॉपी में छपे हो तुम, दिमाग में छापूंगा, जब चाहे तुझे देखूं आईना बना लूंगा. Because copy is not allowed in the examination center. Your brain is always most welcome. So try to copy it in your brain. Okay. So what I was telling you, all salts of ammonium, sodium, potassium, rubidium, and cesium are soluble in water. Remember that, are soluble in water. Always keep it in your brain, then only you can understand. This is solubility. Okay, Hey everyone, say na. Yes, sir. Okay, okay. Now, what I was telling you that once you reacted lead chloride, the white color precipitate with the potassium chromate is soluble in water. But once it is going to form lead chromate, its precipitation will take place and the equilibrium will go more towards the precipitated side. The chemical equilibrium, the Le Chatelier's principle in the La Satle here. So, lead chromate is yellow PPT. Remember what Baba is saying. Lead chromate is your yellow PPT. It's written over here. Yellow papita, yellow papita. Babita, yellow papita. So it's yellow PPT. Got it? Only this much you have to remember. Rest of the things not required. And if you want to add sulfate, add it. You will get white PPT of PbSO4. Now again, solubility is coming. Why the precipitate? Why sir is always talking precipitate, soluble? For that, you have to remember the solubility chart. I will once again make another video for that. Now, Cu2 plus is in group second. And remember that group second basic radical reagent is first add dilute HCl and then pass excess of which gas, Champa? Oh, smell of rotten eggs. Oh, you must have gone to your lab. Some very, very bad smell, foul smell was coming. That was the smell of rotten eggs. Yes, yes, which gas? Hey, Pandu, which gas? H2S gas. So, first add HCl, then pass H2S gas. Then these radicals will precipitate it as their sulfides. Now, see. With excess ammonium hydroxide, okay, they have directly written the conformity test. So, directly, now see, when you add dilute HCl and pass H2S gas, you will get black color PPT of CuS. So, the test of copper is that add first of all dilute HCl, then pass H2S in excess amount, then you will get black color PPT PBS, black PPT. I told my team to write each and everything, but they must have thought that this is the very simple, everyone knows, but my team doesn't know that these kids are very, very basic in the basic level. They don't know anything, so they have forgotten to mention it. No problem, Baba has written. Now see, PBS, if you are going to add to this, let me take fresh page, otherwise you won't be able to understand. So PBS is a black PPT when you add ammonium hydroxide, my dear students. It will form light blue PPT of CuOH whole twice. This is the precipitate. Now, on adding excess of ammonium hydroxide, once somebody is adding excess of ammonium hydroxide, then this PPT is soluble in excess of ammonium hydroxide. In this world, there are only 4 radicals whose hydroxides. So now once again, all hydroxides are PPT except ammonium, sodium, potassium, rubidium and cesium. So once the metal hydroxides, if they are being PPT, and if you add NaOH, they will not be soluble. Only in this world there are 4 radicals whose hydroxides are being soluble in excess of ammonium hydroxide, and in this world there are only 4 hydroxides whose hydroxides are soluble in excess of sodium hydroxide. I will let you know that whenever it is required. But here, this is soluble in excess of ammonium hydroxide, but not soluble in excess of sodium hydroxide. So let me write down each and everything, that if I add excess of sodium hydroxide, it is not soluble. it will not be soluble, no reaction. But if I add excess of ammonium hydroxide, I will get dark blue. This was light blue PPT. Now light blue will convert into dark blue CuNH3 whole 4 OH whole twice. Gets at my place there is no electricity, so see the sweat. But Baba is still teaching you. See the Vira level of teaching, the consistency. See how much H2 is coming out in the form of sweat. See, but the glow on my face, the dedication, I can't compromise with that. So you have to do this also, right? Never compromise with the dedication. Okay, now see, this is a dark soluble complex, dark blue solution, dark blue solution. And now if you add a K4FeCN6 to it, K4FeCN6, you will get chocolate color. I have stored that, what to say, slide or say image in my mobile. My team, can you provide me my mobile, please? I will show you how much efforts I am making for you. Now see, if you are adding K4FeCN6 to it, K4FeCN6, K4FeCN6 to it, you will get chocolate brown, chocolate brown, chocolate brown complex. Now see, my dear students, chocolate brown. This is the notes. Now see, let me show you kids. Chocolate brown. I will share in the PDF also, okay? Don't worry. So, Sensei, please, where is the image? Hare Baba. Yeah, see. Let me enlarge it. Now see. Is it visible? Yes, sir. So this is the color you have to remember, the chocolate brown color. Okay, chocolate brown. Now, my dear students, let me go back. What was written over there? See, and the compound's name will be, see, this is chocolate brown PPT, K4FeCN6, potassium ferrocyanide you have added. On adding potassium ferrocyanide, you got chocolate brown, that is Cu2FeCN6, Cu2FeCN6. So let me write down over here, this chocolate brown color is of Cu2FeCN6, Cu2FeCN6, right kids? Now, this is clear, very much clear to all of you. I think I have to divide this video in two parts. It's very hot, near about 37 degrees Celsius temperature right now, my dear students. So let me complete the basic radicals right now, and I'm supposed to make that acidic one, anions one in the second part, okay? Otherwise, this video will become very lengthy, and I don't know why these apparatives will behave. Apparatives, I'm saying, gadgets, what you call it. Okay. Now this page is over and out. Now let's see the copper, each and everything I have told you. This thing is completed. Now see, it's written over here that with excess of ammonium hydroxide, it forms deep blue complex. It forms deep blue complex, and this is a deep blue complex. This already I taught you, right? Already Baba has taught you, right kids? Now let's move ahead. Whatever was written extra, that you can read once, otherwise it's not that much important, but you can read once. Now Third group radicals, there are three radicals: iron, aluminium and chromium. Better to say plus charge. They are not metals, they are radicals. Radicals means having plus charge. All they are having 3 plus, but out of these three, two are in our syllabus. But aluminium, I would say, no, sorry, chromium is not in our syllabus. Iron and aluminium, they are in syllabus. Chromium is not given by NTS, so cut. Iron and aluminium are in syllabus. Now see, kids, ammonium hydroxide in presence of the group reagent is ammonium hydroxide in presence of ammonium chloride. Now, why ammonium hydroxide and ammonium chloride, and which one should be added first? There is a chemistry of it that belongs to ionic equilibrium, class 11. First, you have to add solid ammonium chloride, and then only you are supposed to add ammonium hydroxide. Remember that. First, you have to add solid ammonium chloride, and after adding this, you are supposed to add ammonium hydroxide. This is the sequence, and it is having chemistry that is Le-Chatelier principle, common ion effect, simultaneous solubility. But right now I will not talk about it. Just if you add it, you will get reddish brown. If you are getting reddish brown color, PPT, as I have told you, all hydroxides are insoluble in water except ammonium, sodium, potassium, rubidium, cesium. So brown color indicates ferric hydroxide, green chromium hydroxide, which is not in syllabus, and gelatinous white. Gelatinous white, remember the name, gelatinous white. Gelatinous white says it is aluminium hydroxide. I hope the names you are getting, names are clear to all of you. Clearly you are getting the names. What I am saying, reddish brown, PPT, Fe3 plus, gelatinous white, Al3 plus. Now let's do the conformity test. This is conformity test, this is conformity test. Simply, these are the conformity test, not very important, only gelatinous white color is important, so I have told you. Now, the very important reaction we know very well, and you should know it very well, that Prussian blue. If you add K4FeCN6, it will form Fe4FeCN6 whole thrice Prussian blue. It is being Prussian blue. So remember this color, Prussian blue of ferrocyanate. Let me show you that Prussian blue color, how it will look like. I have taken image for that to show you. Just see, it's Prussian blue. Can you see? Is it visible? Yes, sir. It's clearly visible that it is being Prussian blue, Prussian blue, Prussian blue color. So Prussian blue color, remember that Fe4FeCN6 whole thrice. Now, one more thing you should know, this one is also given in your organic chemistry as well, that on reaction with KCNS, potassium Sachin, how to remember KCNS? K and CNS, Sachin, ala re, ala bro, Sachin hamara re. So you will get iron Sachin whole thrice, because iron was +3 and Sachin is Sachin -1, SCN negative. So Fe Sachin 3, and its color is they have not given, yeah, given blood red. My team, I was thinking that my team has forgotten, but no, they still remember that it's blood red color, khuni lal rang, blood red. So this is blood red, blood red color, blood red color. Always remember FeCNS whole thrice. This is given in your purification of organic compounds as well, that's organic chemistry. There also you will meet with this same compound. Now let's come to the group number 4th. Group 4th. Now what is the group reagent for it? The fourth group radicals are also precipitated as their sulfides, just like second group radicals. Then what's the difference? Second group radicals solubility, their sulfides Ksp value, solubility product is less, whereas fourth group radicals Ksp value is more. That's why they are divided. In second group there are 8 to 9 radicals, in fourth group there are 4 radicals. From the second group only one is in our syllabus, that is Cu2 plus, and from fourth group 2 are in our syllabus, that is nickel 2 plus and Zn2 plus. So that means in second group radicals first dilute HCl and then pass H2 as gas. Let me tell you the ionic equilibrium. Once you are adding dilute HCl and passing H2 as gas, then the concentration of sulfide will remain less because of the common ion effect of H plus. Equilibrium of H2S will move in the backward direction because it is weak acid, H2S weak acid, and HCl is being a strong acid. Sir, I am not able to understand. Wait, let me show you each and everything. If I say that second group, for second group the group reagent was HCl and that is dilute HCl, its concentration should not increase too much, otherwise even second group radicals will not precipitate it. So the solubility product of second group radicals is less. So for example, if I say that Cu, there was CuS, so CuS is in second group and it is a black PPT. Black PPT, remember that it's being black PPT. It's being black PPT. Now, if I talk about fourth group radicals, so in fourth group radicals, if I take zinc, fourth group radicals, let me take zinc, and here the group reagent is ammonium hydroxide and pass H2 as gas. In both there are H2, in both the group reagents are being H2 as gas and they are precipitated as their sulfide. Why? But we are taking different, there we are taking acidic medium, here we are taking basic medium, so it's from ionic equilibrium. Let me explain. So if I say, if I write down here ZnS, so ZnS Ksp will be more, Ksp will be more. For example, if I take that its Ksp is 1 into 10 is for minus 88, I don't know how much, but yeah, definitely ZnS will have more. Let me take 1 into 10 is for minus 15, right? And in the beaker, if I have taken both of same concentration in the same beaker, if I say Cu2 plus is 1 molar, right? Or let me say 1 into 10 is for minus 1 molar, and Zn2 plus is also 1 into 10 is for minus 1 molar. But if you are dealing with second group radicals, so directly if you're passing H2 as gas, if by chance somebody has directly passed H2 as gas and the concentration of sulfide was, suppose the concentration of sulfide was 1 into 10 raised power minus 2, then in that case the ionic product, if IP exceeds Ksp value, then precipitation takes place. This you should know from ionic equilibrium. For precipitation this is required, and both, see, their concentration is 10 raised to minus 1 and sulfide you got 10 raised to minus 2, 10 raised to minus 3. Their IP is greater than their Ksp. Even the Ksp, this and this Ksp, both will get precipitated, and ZnS actually is dirty white. ZnS is actually dirty white. You won't be able to understand that dirty white along with black where it has gone. So what kids they are doing, first you add HCl. What HCl will do, HCl is a strong acid, will give H plus plus Cl negative, and once you are passing H2 as gas, it will also give H plus sulfide, but this is feebly ionized because it's a weak acid and that is being a strong acid, and due to common ion effect, this the second equilibrium has to go in the backward direction. This has to go in the backward direction, so the sulfide concentration will get decreased. And if this is getting decreased, for example, after adding it was only 1 into 10 is for minus 40. Now see, 10 is for minus 40 into 10 is for minus 1. The K.S.P value of this CUS is 10 is for minus 88. So the ionic product 10 is for minus 1 into 10 is for minus 40, 10 is for minus 41 is greater than 10 is for minus 88. So only CUS will get precipitated and Zn2 plus will remain as soluble one. So you are doing the filtration, Zn2 plus will come down as a filtrate and CUS will remain as a PPT separation, divide and rule. This is the funda. Now, once you are going to reach for the fourth group radical, so what you're supposed to do, I've told you, first add ammonium hydroxide, it will break to form NH4 plus OH negative, and now pass H2S gas, twice of H plus sulfide negative. Now see, this H plus will combine with water and combine with H plus and OH, sorry, this H plus will combine with OH negative to form water, and the equilibrium will keep on shifting in the forward direction, because Le-Chatelier principle says if product is eliminated out, equilibrium will go more in the product direction. So sulfide concentration will keep on increasing, and I have told you that you need more sulfide for precipitation of fourth group. So these are the burning questions the examiner can ask. So I hope that everyone got it, everyone understood why second group reagent is HCl and H2S, why fourth group reagent is ammonium hydroxide, and then pass H2S gas. It is having a sense. Now let me come back to first the color of sulfide. ZnS is, I've told you, dirty white. It's written over here, dirty white. And MnS, no, MnS is not in syllabus. Nickel sulfide is black color. You have to remember these two color, right? Now, the test for Zn2 plus. ZnS is a white precipitate. It dissolves in excess of NaOH. It dissolves in excess of NaOH to form soluble sodium zincate. Very, very important. When you add zinc sulfide, zinc chloride in NaOH or ammonium hydroxide, they will form precipitate, ZnOH whole twice. Now this ZnOH whole twice, this is the only radical in the world, only one radical in the world whom I am talking about. Zn2 plus is the only radical in the world whose hydroxide is soluble in excess of sodium hydroxide as well as ammonium hydroxide. The only one radical in the world, only radical whose hydroxide, that is ZnHOH whole twice PPT, is soluble in both NaOH, excess of NaOH better to say, as well as what I told you, kids. In this world, there are some metal hydroxides whose hydroxides are soluble in excess of ammonium hydroxide. There are some metal hydroxides whose hydroxides are soluble in excess of ammonium hydroxide and some sodium hydroxide, but zinc hydroxide is the only radical which is soluble in excess of both. Okay. Now, one question must be coming in your brain, sir, why you are not writing? So let me write down. These are the four hydroxides. These are the four metals whose hydroxides are soluble in excess of sodium hydroxide. These four, right? How will you remember? How will you remember? Sanjana and Alia are in pub. Sanjana and Alia are in pub. Let me write down. Sanjana and Alia in pub. Right? Now, four metal hydroxides. Their hydroxides are soluble in excess of ammonium hydroxide. Now, there is only one radical you can see in this world whose hydroxide is soluble in excess of sodium hydroxide, excess of ammonium hydroxide, that is Jan. Janu meri jaan, main tere kurban. Jan, 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 Jan. Okay, now, what I was telling you kids, zinc we have done. Now, zinc with K4FeCN6 will give bluish white PPT. Remember that. That copper NH3 whole 4 twice, CuNH3 whole 4 2 plus complex, that was blue color complex. That one reaction with potassium ferrocyanide K4FeCN6 was producing what? Chocolate brown. Fe3 plus has given Prussian blue. Remember, same reagent K4FeCN6, Cu2 plus chocolate brown, Fe3 plus Prussian blue, Fe4FeCN6 whole 3 ferrocyanide. Now Zn2 plus is giving bluish white PPT with K4FeCN6. Three different colors we are getting. Remember that. Now nickel, only one thing is important, rosy red PPT. Brilliant rosy red PPT, NiDMG whole twice. NiDMG whole twice. Dimethyl glyoxymato. This is the radical, only this one. And the complex is stabilized by hydrogen bonding. All these are the questions. My team has really done a hard work. So huge round of applause for my team kids. Okay, now you got it. Now next. Nickel, so already I have told you, rosy red color, this is very important, right? Now, out of these three, only magnesium is on our syllabus, magnesium Mg2 plus. For that you have to remember sodium hydrogen phosphate reacts with sodium hydrogen phosphate and ammonia, and it gives white needle shaped crystals. It forms white crystalline precipitate, or in place of this they can give you white needle shaped crystals. White, very tough to visualize in the lab, very thin, white needle shaped crystals, white needle shaped crystals. Magnesium is okay. Now, let's see barium, strontium and calcium. First of all, the flame test. Flame test, barium, apple green, strontium, crimson red, calcium, brick red. Now, the group reagent is ammonium carbonate and ammonium hydroxide, and they are precipitated as their carbonates. They are precipitated as their carbonates. So, you see, barium gives yellow PPT with chromate, barium chromate, banana. Banana chromates are yellow. Barium chromate and sodium chromate, they are yellow. Strontium gives white PPT and calcium gives white PPT with oxalate. Now, this is all about kits. This is all about basic radicals kits. So I hope that everyone got it and try to apply your brain. The acidic radicals salt analysis, I will make a video if you are able to understand this video. The thing which you are unable to understand, do let me know in the comment section. I will further make video after getting your queries, but don't skip this video because it is really going to give you 20 to 25 marks. So win-win position you can be, and if you're going to leave it, it's very tough for government seat, and for rank definitely it's most important, even for selection if you belong to any state. If you're new to this channel, if you're really liking it, subscribe the channel and let other students should know, because sharing is caring, and if you're helping others, Almighty God is going to help you out. Right? Bye bye. Take care.